ATP synthase. It's the first rotary engine. God made it a long time ago. And it's actually going to rotate and create ATP as it rotates around, and it's kind of interesting. Another motor in the same first cell that had to be there.
This animated sequence shows the ATP synthase enzyme in operation. The animation is based on an incredible series of scientific discoveries. Only the colors show artistic license. ATP, or adenosine triphosphate, is the energy currency of the cell. ATP is produced by a tiny molecular rotary motor, rotating at up to 7,000 RPM. These are so small that 100,000 would fit side by side in a millimeter. A current of protons drives the motor, unlike man-made electric motors which use electrons. This portion of the enzyme is where adenosine diphosphate is combined with a phosphate ion in the presence of a catalyst to produce ATP, which is then released, making way for the next cycle. A top view of the enzyme shows the sequential operation. Almost every biochemical process in your body requires ATP. Such a nanomachine exhibits all the characteristics of super-intelligent design. ATP is vital for life, and many of these motors were needed before the first living cell could exist. An evolutionary impossibility.
So, evolution is formed around random chance mutations and natural selection. The mutations that are best suited for the environment are going to be the ones that get passed on, they're going to be the ones that make it. Yet that first cell still had to have all these motors that are non-living that worked in that very first cell. The next problem, skipping the next slide, going to number 13, is polystrate fossils. These are fossils that stand vertically in layers of rock that are dated at millions of years old each. So, my point here, there's like a layer of rock here that would be the oldest layer at the bottom. And you go a little higher and there's another million years newer rock and another million years newer, and it keeps going, but somehow this tree managed to live through millions of years of rock building up around its trunk. Evolution doesn't even try to explain it other than, let's go to the next rock. A good explanation for how so many layers of sedimentary rock could end up around a tree is a flood. Maybe a flood put a whole bunch of mud around a living tree at one time real fast. And then the mud would separate based on density, and that's how you would get your layers. Simple enough. Now, of course, they're layers. They make them work. They make them show how the bottom ones are older than the top ones based on their inconsistent radiometric dating system. That's polystrate fossils. The next problem is comets. Comets orbit the sun just like planets do, except planets tend to have a circular orbit where comets will have a more oval orbit. And the comet goes out way away from the sun where it's far enough that it's not being melted anymore. But when it gets close enough to the sun that it starts melting, that's when we can see its tail. We see the melting water behind the tail. So, you notice in this picture, the comet starts melting here, it follows the orbit all the way around until it gets far enough away that it's not melting anymore. And then if this were Halley's Comet, probably the most popular comet, it's going to come back every 75 years following its orbit. We still see Halley's Comet. What's happening to a comet if it's melting? It's shrinking. Should be. And the problem there should be fairly obvious now. If it's been orbiting around the sun every 75 years for 4.6 billion years now, what would have happened to all that ice? It should be gone by now. And there should be no comets left in the solar system. Of course, evolutionists have come up with the Oort hypothesis, where there's this Oort cloud out there somewhere that we haven't found yet that has comets in it, and it just releases them every once in a while, so that we can have more for us to see. Hypothesis. No way to test that, obviously, which, if you remember from scientific method, what's the point in having a hypothesis if you can't test it? finally, my next problem, sea floor sediment. When it rains on Earth, dirt erodes, it goes to the oceans, and in the oceans we end up with dirt from the land, and we can measure that dirt. It's measurable every year. About 20 billion tons of sediment is deposited into the oceans. And you'll notice from this diagram that every year about 1 billion tons is carried into the Earth's core by the tectonic plates as they shift, which leaves another 19 billion tons of sediment that should be building up on top of the sediment every year. Problem here is we should have a whole bunch more sediment in the oceans than we do if the Earth were 4.6 billion years old. According to this, about 250 times more than we do. Now, you may be wondering, if we're only 6,000 years old, we should have less than 250 times worth. Well, the flood can account for that. The flood may have put a little bit of extra out there. So, the problem here is not enough sediment for a 4.6 billion year old Earth, and this measurement should have increased through time. When the Earth had more dirt on it, there should have been more dirt being put there, so there actually should have been more in the past there than there is now, but that doesn't back up their dates. And one last problem I've got, I don't have a slide for it, is the human population. Our human population is about 7 billion right now, which based on models is almost exactly what you would expect it to be if about, I don't know, 8 people survived a flood about 4,400 years ago. So where's the problem there? If that's what it should, if that's what the model looks like, 8 people surviving a flood 4,400 years ago, now we have 7 billion people, then what's the problem with only having 7 billion people? It's too small. We should have way too many people on this Earth for it to support right now if we've had people here since 250 million years ago, which is what they'll tell you. Alright, we are skipping the next 4, I think. Alright, this is just a minute video from the Creation website to kind of reflect on what you just heard. And then, if you got any questions, we'd be glad to.
Welcome to Creation Minute. I'm Eric Oven. Do you remember the first time somebody told you there is no God? You were thinking, no way. I mean, you'd have to be highly educated to be that ignorant. And you're right. You wouldn't look at a building and wonder if there was a builder. You don't look at a painting and question if there was a painter. At the same time, we do not look at creation and wonder. Was there a creator? The Bible even tells us the invisible things in creation are clearly seen. Everybody believes in God, but some have decided to suppress that truth. Don't suppress the truth. Trust in Christ. To learn more about creation, visit us at creationminute.com.
Well, to wrap it all up, you'll probably ask the question in the future to somebody teaching you this: where did the first cell come from? Where did the universe come from? Good questions that won't be answered, but of course they're combated to that would be, that doesn't mean we shouldn't keep studying it. We'll figure it out one day. So, what can I say? Fight this. Don't be respectful to your teachers. I will say that. They do have the pen on you. But other than that, you don't have to believe it. Just know it for a test. Any questions about anything? No? Cool. Well, thanks for your time.